Hello. Hi, everyone. Welcome back to the Ready for Merge podcast show hosted by yours truly, Christine D. Kim. I'm glad to be back after a very restful kind of week-long break. Celebrating American Thanksgiving with the fam. But back again, covering Bitcoin and Ethereum protocol development. I am here with another bi-weekly brief, which will update all of my listeners on the latest code changes that are ready for merge, being worked on and about to go live on the two most valuable open source protocols in the world, Bitcoin and Ethereum. Today is a very special day. It has been quite the week because this is the week where Ethereum's Fusaka upgrade goes live. There was a little bit of a message in the live stream chat show on the stream. We are indeed talking about Fusaka today. At WADS2S. Thanks for joining the live stream. It's not every day that Ethereum undergoes a hard fork upgrade. Indeed, they do this almost every single year. So sometimes for Ethereum ecosystem stakeholders, it can get kind of repetitive because of how many hard forks Ethereum does. But as I've stated on prior Ready for Merge episodes and on, as I've stated in a recent Substack post that I did on just the coordination costs of the hard fork upgrade, both of which I'll link to in the show notes, these are still significant and monumental milestones in Ethereum development. So we are going to get into it. We're going to talk about what is going into Fusaka, like what changes what code changes are expected in the upgrade, what kind of impacts it'll have. We're going to talk about how to watch the upgrade today, happening in a couple hours. And more importantly, what to be watching for when you are watching an Ethereum upgrade happen in real time. We've also got some Bitcoin updates for everyone as well. Exciting news on that front too. A new PR has been merged into the Bitcoin Core code base. A pretty significant one also. I think we talked the last time about the C header API, and that was a big merge. We got another one, Cluster Mempool, the main PR for the Cluster Mempool initiative has been merged as well and finalized. Developers are just working on the finishing touches to that initiative, to that project. We're going to talk about what stakeholders this PR impacts the most. Miners, Bitcoin miners, any Bitcoin miners in the room, listen up because this will impact you and hopefully make you guys more money. And we're going to talk about how soon you guys will be able to see the features, the Cluster Mempool features, get access to them in Bitcoin nodes and in Bitcoin Core software. So that's what we're going to get into today. Thank you guys again for joining me on the live stream. Or if you're watching the recording of this episode, let's jump right in. We're going to actually start with the Bitcoin updates because there's some other Ethereum related news I have on the back end of the show. So I like to make my conclusion, the outro of the episode, like a continuation of what I'm talking about in the meat of the episode. So I'm going to start with Bitcoin this week, and then we'll get into the Fusaka stuff. But as always, for all of my listeners, there will be timestamps to show you when and where the Bitcoin update starts and then when the Ethereum update starts. So I'm going to do a little tag here, Bitcoin updates. Ta-da! Here we go. Yes. So every Thursday, Bitcoin developers, similar to Ethereum developers actually, have a weekly developer meeting. And on the most recent one, last Thursday, developers celebrated the merging of the Cluster Mempool PR. I've never done this before, but I'm going to do also a little cheering. Wow, that cheering clip is 36 seconds long. I just wanted like a couple of minutes of cheering. But yes, they celebrated the merging of this PR. It's a PR that's been worked on, I believe, since 2023. The idea for it has been discussed and has been being worked on for a couple of years now. And they finally wrapped it up. This PR, the Cluster Mempool PR, is a PR that updates the logic and the reasoning in Bitcoin nodes for how Bitcoin nodes handle unconfirmed Bitcoin transactions. So every Bitcoin node keeps a log, a record of unconfirmed Bitcoin transactions that will be included in the next Bitcoin block. And this is called a mempool. The mempool of Bitcoin at times very full, other times not that full. And there is logic and reasoning in a Bitcoin node that will, of course, first of all, dictate, is this a valid transaction that I should even be storing in my node and propagating to other nodes? And of course, if the transaction is invalid, it doesn't abide to the rules of the protocol, then that transaction is not considered a valid transaction by the node, and it's dropped. There's also policies. We've talked about certain policies in Bitcoin Core nodes around transactions that are considered valid and will be relayed to other nodes in the Bitcoin network that are valid by consensus rules. They are valid transactions, but are simply not transactions that a particular node will relay to other nodes. Particularly on the sense of, does this transaction have too much arbitrary data attached to it? That was the main controversy around Bitcoin, the latest major release of Bitcoin Core software, where there was a policy change that was uncapping the op return limit, which would allow just simply more arbitrary data to be attached to a Bitcoin transaction and would allow these transactions to be relayed throughout the Bitcoin network. And now these are policies that node operators can adjust themselves, but there's also default settings are very powerful in open source software. So the default setting for that policy had changed in the latest Bitcoin Core major V30 release. So when it comes to the logic around unconfirmed transactions, around the ways that nodes handle the mempool in particular, there's also additional features. So there's a feature called replace by fee that will allow users to update the fee attached to any unconfirmed transaction that they've sent over. So if you notice that your transaction that you've sent into the Bitcoin mempool is not getting included into the immediate next Bitcoin block, you can bump the fee to prioritize it and signal to the network that this is a transaction that I would urgently like to get processed in the next Bitcoin block. So there are features like that and other kind of mechanisms that allow Bitcoin nodes to prioritize this is a very valuable transaction or a high priority transaction that should be propagated ahead of other transactions. This is a transaction that is dependent on this other transaction. Lots of different kind of like rules at play, but currently with the way that Bitcoin nodes are operating up until the most latest major release, Bitcoin V30, sometimes the rules clash. And sometimes they result in Bitcoin nodes propagating or signaling a priority for a transaction that perhaps shouldn't be prioritized, or dropping lowering the priority of a transaction that should actually be prioritized, and miscalculating really the value of these transactions. And there's a great delving Bitcoin research post by one of the core developers that has focused quite a bit on the Cluster Mempool project, and he really shows the case studies, like the examples of when the current mempool policies and features don't actually result in the most valuable block that could be created, that miscalculates, misinterprets the dependencies of Bitcoin transactions and their value, and miscalculates kind of ultimately like the total fee for a block. and funks up the fee estimation for transactions. So there are times when the mempool policies are insufficient. Cluster Mempool is the PR that introduces advanced reasoning and logic for Bitcoin nodes to be able to cluster, bundle dependent transactions together, and more accurately be able to assess which transactions should be prioritized over others. And this is primarily very, very good for Bitcoin miners, because for Bitcoin miners, they obviously want to create the most valuable blocks they can. And if they're leaving money on the table in fees, then that may impact their bottom line. So this is a PR that is, particularly beneficial for Bitcoin miners. It's also, of course, very beneficial for node operators of Bitcoin, because now your node will be able to respond more effectively to fluctuations in mempool activity. So when you see that the mempool is extremely full, there's a ton of transactions, your node will be smarter about which pending transactions to drop and which ones to keep around and which ones to propagate based on their fee, based on the reasoning, the logic of some of these new rules and policies that have been implemented via Cluster Mempool. And I'll note that Cluster Mempool as a PR, as a feature, as a code change in Bitcoin Core, it is another policy change. It's another policy change for how nodes reason about unconfirmed transactions. It does not change anything about the validity of Bitcoin transactions. It is not a change to Bitcoin consensus protocol. The Bitcoin protocol still works the same way that it has for the last several years. This is not a soft fork change. This is simply a change for policy, the policy that Bitcoin nodes use to hopefully be able to operate in a more efficient, computationally resource efficient way, and hopefully a more resilient way to be able to respond to fluctuations in mempool activity without, edge cases of like denial of service attacks or finding degraded performance when there's a high fluctuation, suddenly a large amount of on-chain activity happening. So that's kind of the gist of what the Cluster Mempool PR is. Hello, friends. Hello, Daniel Gray. I just did a little quick chat in the in our live stream chat because I saw some of the messages pop up. I am monitoring the chat, so in case anyone has any questions, feel free to chime in there. That is a little benefit from joining in on the live recording. I will actively do a live Q&A as I go through this stuff, this exciting but sometimes dense technical material. So that is the most recent major PR that has been merged into the Bitcoin Core code base. Now developers are really focusing on polishing the PR. They're creating documentation for it, for wider testing of that PR. And that PR has been merged into the main Bitcoin Core development branch. So because all of Bitcoin Core software development is open source, of course, you can always see the features being worked on in Bitcoin happening just openly on GitHub. But now if anyone goes to the official Bitcoin Core repository, this PR is one that you'll be able to see in its finalized form in the main branch. There are additional PRs related to it that are still pending. And normally, even when these features do get added to the main branch, the main development branch for Bitcoin Core, they're not adopted by all Bitcoin node operators as these PRs get merged. That is not the way Bitcoin Core software development works. Usually, Bitcoin Core developers do about 2 releases, 2 cuts of the main development branch a year. So all of the code changes that have been finalized between the previous release, the previous major release, to the next one, which is about a 6-month period, they bundle all those together into one one release, so they call it, with documentation, again, release notes about all those features, like summarizing all the features that had been worked on and finalized over that time period. And the most recent release, major release, happened in October, this October. So the next one, V31 for Bitcoin Core, is coming up in April, which is probably when most node operators will choose to adopt or not these features, the Cluster Mempool PR, because the Cluster Mempool PR, since it was finalized after the V30 release, it's going to go into the V31 release. Again, because it's not a consensus change, this is one of those code changes that developers can take their node operators, can take their time adopting. They don't need to immediately adopt that code change as soon as it goes out, or they'll be like booted off the network. It's not a hard fork. Bitcoin development culture is very much about backwards compatible changes, so that node operators have the flexibility to choose to upgrade on their own time. So that is the status of the Cluster Mempool PR. If you are a Bitcoin miner or a node operator that is very interested in getting an advance, tryout of these new features, just go to the Bitcoin Core main GitHub repository, and you'll see that it's one of the most recently merged PRs that you can already start to review and even maybe participate in the polishing of it as developers get it ready for the major release, for the V31 release coming out in April. Most likely, anyone who's not keeping up to date on a monthly basis or isn't urgently needing the Cluster Mempool, or urgently expecting the Cluster Mempool features, most likely you'll probably see it just kind of like automatically become the default in your node coming sometime in April, next April, once the V31 release is cut. So yes, I have a little bit of a write-up on this PR that went out this morning that I'll link in the show notes of today's episode if you want to get more information and find direct links to this code change, which you can read about in more detail on the Bitcoin Core GitHub page. So yeah, kind of exciting. Another successful code change / feature research developed and finalized in Bitcoin Core. So yes, clap, clap, clap to all the Bitcoin Core developers that worked on this. Let's talk now about Ethereum. I'm actually doing really great on time this week, which is amazing. I always say on these episodes I feel rushed, but not today. Let's talk about Ethereum. Yes, it's a big day for Ethereum because Ethereum is going to undergo a backwards incompatible upgrade. One of those upgrades where all node operators do have to ensure that they have the most updated software, the most updated client software, or at least the software that activates the necessary code changes, at the very least integrated and adopted and downloaded into their nodes, their computers by a target date. Because if they don't, these nodes that have not upgraded to the relevant software will be booted off the network. They will be validating a different protocol, a different chain. So this upgrade that is coming up in just a couple hours, we are recording this at 11 a.m. ET, December the 3rd. The Fusaka upgrade is going live on Ethereum Mainnet at 4:50 p.m. Eastern Time. So about like 5 hours. In 5 hours of the show's recording, the Fusaka upgrade is going live. And just on the note of upgrading, whoever is running an Ethereum node, note that certain client software, oh my gosh, I had a little bit of lipstick on my teeth. They're great that I have a camera that even shows that. But anyways, there are 4 clients that have recently released new versions of their software for this upgrade within the last 7 days, which is kind of cutting it close. Granted, some of these new client releases are not mandatory for node operators to utilize, but some of them are. So one kind of call out I wanted to make is if anybody is a Nimbus node operator or using the Nimbus client, please note that if you haven't checked their client software releases in the last 7 days, there has been a new release fixing a bug that hadn't been previously discovered, but was recently discovered in the Nimbus code base that you do need to update to. There's a couple of other client releases that have come out, 3 other ones, but I'm going to link in the show notes to the Substack post I did, just summarizing all 4 of those and highlighting all 4 of those client releases. And in that same post, we have a little explainer of what's going into Fusaka and what the heck the Fusaka upgrade actually does. The Fusaka upgrade is a bundle of 12 different features, 12 different Ethereum Improvement Proposal, EIPs. Technically, it's 13 EIPs if you include the JSON RPC change that basically standardizes how fork configurations are done in all of the Ethereum clients, or at least I believe, I think it's all the Ethereum clients. It could be all the Ethereum execution layer clients. For Ethereum, again, there's 2 different types of software clients that node operators need to run together if you want to operate a fully functioning Ethereum node, an Ethereum execution layer consensus client, and then a consensus layer client, and then a third piece of software called the engine API that actually allows those 2 CL and EL software clients to communicate with one another. It's gotten more complicated over the years to run an Ethereum node, but there's work that's being done. Even coming out of the recent Ethereum conference, DevConnect, to try and simplify things back down for Ethereum node operators. But anyways, it's 13 EIPs if you also count the JSON RPC change for configuring upgrades on Ethereum. So Fusaka is about the same number of features, if not more features, than the prior upgrade that went live on Ethereum earlier this year called Pectra. And Pectra at the time was thought to be the largest Ethereum upgrade by number of EIPs. And lo and behold, we've got Fusaka coming up later today with 13. So a lot of changes coming up. How am I going to get through all of this? Well, I'm going to bundle it. I'm going to bundle these code changes and just kind of summarize, give you guys the bird's eye view of just the most important ones. So 4 really important impacts of Fusaka that my listeners need to know. This is what's going to change about Ethereum after 5 hours. Within 5 hours or after 6 hours, from 5 hours onwards. I'm not saying that right. But you get what I mean. I know you do. First impact, layer 2 scaling. The Fusaka upgrade is going to basically more than double the block space for blob transactions. So right now, there's a maximum or a target of about 6 blobs per block that can be included. And this target target for blob transactions is going to increase over the coming month after Fusaka to 14 blobs. It's going to go from 16 to 14 through Fusaka, and then 2 additional hard forks, which are called blob parameter only hard forks, that will adjust the blob capacity 1 week after Fusaka, and then I believe like 4 weeks after Fusaka. And blob transactions are a specific type of transaction that is particularly useful for layer 2 rollups on Ethereum, because it just gives them a dedicated fee market and a dedicated block space to be able to commit arbitrary data down to Ethereum. And this is very important for layer 2 operations. They do this quite frequently. They batch together user transactions on their protocol and commit them down to Ethereum for additional data availability and verifiability. Because Ethereum's network of decentralized node operators is significantly more larger than these newer layer 2 protocols. So this is great. Fusaka will introduce significant scaling improvements for data availability for layer 2s to be able to operate more cheaply on Ethereum with, again, that more than doubling of blob space. Second, pretty important impact of Fusaka is the rest of block space for all the other types of transactions, the regular transactions. You know, you want to send ETH to another friend on just layer 1 Ethereum. The block space for the regular block space of Ethereum with regular transactions, that has already increased by 33%. And there's a bunch of code changes in Fusaka that allow developers to continue to increase the block size of Ethereum just for regular transactions again after the Fusaka upgrade. So on the latest developer call, which happened on Monday, developers were talking about even potentially doing another block gas limit increase, which simply increases the size of an Ethereum block, as soon as, say, like sometime in January of next year. So lots of code changes and features that will allow developers to more accurately test exactly how big can we make Ethereum blocks without negatively impacting the decentralization of Ethereum. One of those layer 1 scaling improvements has already gone live because that's the default setting of now more than half of the validators of the node operators on Ethereum. So layer 1 scaling, layer 2 scaling. Two other important impacts: smart contract development improvements. So anyone that is trying to code applications or anybody that's trying to build different services that use smart contracts on Ethereum, there's going to be a new opcode that will make a certain mathematical operation more cheap for your contract to do. It's called counting leading zeros opcode. And this is just apparently like a function that a lot of different smart contracts rely on and has been a bit overpriced or more expensive for smart contract developers to use, even though it doesn't take up relative to the computational resources that it takes up to actually do that mathematical operation. So now there's an opcode that will be able to price it more cheaply. There's also a precompile that will allow smart contracts to be able to integrate better with mobile devices like iPhones and Android devices and hardware, crypto hardware wallets. So some nice new little features specifically for smart contract developers to improve their user experience when building services on top of Ethereum. There is also, last but not least, a little code change in clients that was not necessarily, it did not require any consensus level changes. It did not require a hard fork, but did require a bit of coordination between clients in advance of the upgrade to enable, and that is history expiry. So this is particularly saving Ethereum node operators bandwidth when they do an initial sync. So instead of having to download all of the block history data from Genesis back in Ethereum in 2015, now they're a certain data up to the merge upgrade, which was sometime in 2022. That kind of data is not required for an initial sync, which just helps node operators be able to connect to Ethereum without using as much bandwidth. So yes, those I would say are the biggest impacts of Fusaka. The way that I would summarize it in a nutshell. Scaling for layer 2, scaling for layer 1, smart contract developer user experience, and the node operator user experience. Those are kind of like the 4 major improvements. And yes, I will indeed answer this question and share it and show it on the stream. So WADs 2S asks most underappreciated EIP and why, and how would you assess the risk of the upgrade overall? We are going to talk a little bit about the risk of the upgrade in just a few seconds, but in terms of which I think is the most underappreciated EIP, not in terms of impact. I do think that's the scaling, the increase, the peer DAS EIP that basically allows developers to scale blobs is definitely the most impactful in terms of an ecosystem and an Ethereum protocol level perspective. But the most underappreciated EIP in terms of changes in Ethereum protocol governance and Ethereum protocol development process is the BPO hard forks. This has never been done, of automating multiple hard forks within one hard fork. And there have been multiple questions of, well, how are we going to document and process now moving forward BPO hard forks in relation to regular hard forks? Fusaka is not one hard fork upgrade. It's 3 bundled into one. So I think the BPO hard fork is underappreciated in the sense that it's changing what individuals or what stakeholders can even understand as what we think about a hard fork upgrade. It's not just like a dichotomy between soft fork upgrades and hard fork upgrades anymore. Now it's like within hard fork upgrades, there's hard fork upgrades that have BPOs and others that don't, and how frequently developers leverage BPO hard forks, how quickly they can deactivate certain BPO hard forks if they find that the increases in blob scaling are just too much for the network to handle. These are all questions that developers have been talking about on the calls, and that developers really will not know until these BPO hard forks go live on mainnet and developers have practiced using them a couple times and really hammer out how BPO hard forks are going to be normalized into the Ethereum fork development process. So yeah, that is the one that I would say is very underappreciated and one that I'm going to be watching quite closely. Speaking of how to watch the Ethereum Fusaka upgrade that's coming up in the next couple of hours, very quickly on the back end of this show, as I know I'm about up to time. Number one, there's going to be a live stream where a lot of Ethereum developers are going to be talking about the upgrade in real time as it happens. I'll link to that live stream. It's hosted by the Ethereum Foundation. No surprise there. The Ethereum Foundation. There's also a public R&D Discord channel that Ethereum developers have created a Fusaka chat for real-time communications. Any developers that are not part of the live stream are likely going to be monitoring the chat and sharing updates about how the upgrade is going in that Discord chat. Third, there are block explorers, which are just websites that show you a live view of the on-chain activity and block progression of open source protocols. There's block explorers for almost every chain a major cryptocurrency out there, even the small ones. Of course, Bitcoin has many. Ethereum has many. I'll link to one of my favorites, or one of the ones that's used most frequently in the Ethereum ecosystem, called Beacon Chain, into the show notes. And finally, last but not least, I'm also personally going to be sharing updates and watching the upgrade happen in real time in my subscriber chat. Yes, I have a Substack subscriber chat for my premium subscribers. So if you're interested in joining the chat and getting access to that kind of information, real-time information, consider subscribing, becoming a premium subscriber. So those are kind of the ways I would say is the way to watch the Ethereum upgrade happen, what to be watching for. And this is where I'll talk a little bit about risk too. There's 2 things that you normally look for when an Ethereum upgrade happens on chain. Number 1, you look for network participation rate, which is how many validators are successfully attesting to the head of the Ethereum chain. Because it's a hard fork. You're basically creating a new version of the Ethereum protocol. You're trying to assess how many validators have successfully been able to migrate over to that new protocol and are correctly validating that same protocol with new consensus rules. So that's network participation rate. The block explorers that I had mentioned, Beacon Chain does track this. I'm sure developers will be talking about it on the live stream and the Discord. I'll be watching out for it as well. The second is network finality. This is kind of like a milestone that the protocol reaches every 2 epochs. I believe every epoch is something like 6.4 minutes. But every period of time, occasional period of time, the network undergoes kind of like a finalization process that makes all the transactions up to that point and all the blocks verified up to that point very, very hard to revert. Virtually impossible to I don't know, change, which is different from Bitcoin, which is that the longest chain always rules. So technically finality is kind of ambiguous. You just kind of see, well, what's a long enough chain that you think is like how many blocks should I wait before thinking that the transactions in that block are truly final? And for most exchanges, they kind of just like eyeball it at like 3 or 4 blocks in. You can think of all the transactions. If at least 3 or 4 blocks have been verified on top of the current block, then you can think of all the transactions in that current block as valid and unlikely to be reorged, unlikely to change. But for Ethereum, there is kind of like this idea of a standardized way to understand finality. And it just indicates that the network is significantly more secure up to that point. So we're waiting for the network to finalize the Fusaka block. So when the upgrade goes live on a particular at a particular epoch or a particular time, we're waiting for that block to reach a state of finality where it's very unlikely that all the code changes and features that have been finalized in that block will be reversed. So those are 2 things. What's kind of special about Fusaka and what I would encourage, what I heard from a client developer, Preston Van Loon, shared with me, actually on an Unchained episode, which I guest hosted, which hopefully that episode will be coming out soon at some point. I'll share it with folks if people are interested. One thing to be watching out for is blob activity right after the fork. So right after Fusaka happens, it will be important to watch for, can layer 2s still send blob transactions to Ethereum? And do these blob transactions contain real data? Of course, with PeerDAS, with some of the features in Fusaka that impact layer 2s and allow developers to scale data availability on Ethereum, there are some changes in the formatting of blob transactions in their proof, in the proofs that need to be attached with these blobs. And for one of the prior test nets, layer 2s were caught off guard about some of these changes. So watching for blob activity in real time, I think is going to be another important indication of the network of the upgrade success. Has Fusaka gone well? There's like certain metrics like participation rate and finality that indicate the health of the network, but there's also kind of more targeted metrics related to blob activity that will show whether or not the blob transactions and the scaling changes that are coming to Ethereum have also been implemented correctly, and layer 2s are still able to utilize Ethereum for data availability smoothly. So those are some important things to be watching out for. Again, as I mentioned kind of earlier, this is not the only hard fork upgrade that Ethereum will undergo in the near term. Next Tuesday, there's the first hard fork for the blob parameter only hard fork. It's going to bump the blob data availability. It's going to bump the target from 6 blobs to 10 blobs. And then on January 7th, there's going to be a second hard fork at BPO2 that will bump that number to the final number, pre-scheduled number, which is going to be a target of about 14 blobs per block. And again, for these BPO hard forks, I would just watch it and treat it similarly to the way that I'm treating Fusaka, looking out for network participation rate and finality after these blob parameter only hard forks, and also looking to see if, to see making sure that the blob transactions are coming through well from layer twos to the layer one, but also to see how the validators and the node operators themselves are handling the increased capacity. In theory, the increased capacity, there shouldn't be any node operators that are unable to continue with their operations after these upgrades, even without upgrading their bandwidth or their hardware. But I do believe that there will be some home stakers, more recreational validators who operate nodes just for the fun of it and are not perhaps on the highest grade equipment, that may find it difficult to produce blobs may find it difficult to produce blocks with the highest number of blob transactions possible, especially as the blob capacity continues to increase with these BPO hard forks. So one of the things I'll be looking out for is how the home staker community is doing, and how their operations are going after these BPO hard forks, in the aftermath of the BPO hard forks. We won't know that until a couple of weeks into the upgrade, of course. The ETH Staker Discord, I would say, is another great resource, especially on the front of home stakers, to just know what the reaction is from that stakeholder group in Ethereum to these code changes that are going to be activated imminently. But also even just looking for things like the number of orphan blocks. Are there any blocks that are being missed because certain node operators are not able to produce the block in time with all these new scaling updates. Now, again, that's not what developers expect, because they've designed this in such a way where all node operators should be able to still operate comfortably. However, I think those are concerns to be watching for. So on the question of the risk of this upgrade, overall, I think because of how many features are going live, because of how much more quickly, as I've discussed in prior episodes, Fusaka has been developed compared to prior episodes, and some of these major scaling changes that are coming in Fusaka, I think there is a greater risk of, I'm a little bit more concerned about this upgrade in terms of how it'll go than, say, prior upgrades. But that being said, other developers are definitely not. I was, again, talking to Preston earlier for the Unchained guest episode hosting, and he was sharing that though the number of EIPs is the same, if not larger, than the prior Ethereum upgrade Pectra, the parts of the Ethereum code base that these features touch is actually a smaller surface. So in terms of technical risk, I think the technical risk is similar, if not less. In terms of ecosystem impact, how L2s will respond to this, how home stakers are going to respond to this, I'm a little bit more wary and going to be watchful for Fusaka. And on that note, I have a little bit of an exciting announcement. On Fusaka, there is one other amazing resource that I want to highlight on how any listeners that are interested in Ethereum protocol development and how this Fusaka upgrade has gone and impacts the network. If you're interested on all this stuff, next Wednesday on the next Ready for Merge episode, I'm going to be doing the first live guest episode recording with two developers that have been very close to the entire Fusaka development process. One of them is a client developer, and the other one, I kind of like to think of him as the taskmaster for Ethereum upgrades. Both of them are going to be joining me on the Ready for Merge show to talk about the Fusaka upgrade, how it went, and how the BPO, the first BPO hard fork ever to go live on Ethereum mainnet went. Yeah, so please do stay tuned for that episode. It's actually going to go live next week. We're going to record it live 1 hour earlier than my regular Ready for Merge episode. So these shows are bi-weekly briefs are usually recorded at 11 a.m. ET, but next Wednesday, the show will go live 1 hour earlier. So just mark your calendars if you do plan on coming in and joining the live stream. But I'm very excited because I'm sure that they'll have really great insights to share on exactly how the upgrade went. So yeah, so expect to hear more and get the full TLDR on the aftermath of Fusaka on next week's Ready for Merge episode. Yes, that is all. I know I went over time, but I felt like today was a bit of a special day. It's a special episode. Today's the day Fusaka goes live, and I wanted to make sure everyone is well up to date and give you guys the update on the latest code changes that have been merged into Bitcoin Core. Thank you all so much for watching and tuning in. Thank you, Codigo, for joining the live stream as well and for tuning in. Thank you to everyone who is also listening via the recording of this episode. You are all of you are now officially caught up on what's ready for merge in Bitcoin and Ethereum. If you want any more information on what I talked about in today's show, please do check out the show notes of today's episode. Be sure to like, subscribe, share, do all the things wherever you're getting this episode on whatever channel you're getting this on. And I hope that you'll be back to listen/watch again next week. So yes, have a great week, everyone. Thank you. Bye.